Okay, we ready? Yeah. All right. Last lecture, I asked for $5 what the first name of the angle curve guy was and where he was born. I only ask questions where the answers are Germany, right? So his name was Ernst. I of course have no cash, but you came to answer the questions. I'm going to give you an IOU for $5 to be cashed in next lecture, and you get to keep that. So if I ever win anything or become famous, you can auction that off on eBay for another 49 cents. All right? Yeah. So German statistician from Dresden. The American pronunciation is of course Ernst because it's like Ernie and Bert, but in Germany it's Ernst, yeah, which also means serious, right? In English. So he's a very serious statistician. Thanks, Max. All right. Where are we at? 2 weeks away from midterm 1. Are you feeling the pressure mount? I'm about to dump a whole bunch of material onto B courses. Pay attention, pay attention. This is important stuff. This is where grades come from. This is the birds and the bees equivalent of a class, right? Grades come from Max writing exams and giving them to you. Now I'm going to give you information about the exam. So the exam, because I'm getting a lot of emails, I will hand you a stapled together set of sheets that will have printed on them the actual questions and enough room for you to do the whole exam. You do not need to expend money on blue books, green books, yellow books, or anything. You're excited because you're saving 25 cents, and the GSIs are extremely excited because you don't go from question 1 to 9 to 3B to 3A to 4C, right? So all you need to bring to the exam in 2 weeks is a ruler. Make it a see-through ruler. Makes your life easier. A couple of pencils, an eraser, and a pen or something. Your giant brain, bottle of water, and lots of economics in your giant brain. That's all you need. You do not need calculators. You don't need to do math. All you need to do is intuition. There's no math on my exams, right? I can make your life incredibly hard without ever having you add anything, all right? If you want verification of that, I can give you numbers of some former students who still hate me. That's that. Questions. There will be a review session that I will teach before the exam. I just need to get a room. Question. You can use pens if you want. You can't use red or green. That's the only 2 rules I have because that's how we grade. The GSIs get the all-powerful red, and I get, what's the coolest lightsaber in Star Wars? The green one, right? So I get the green pen. So those are the only 2 colors that are off limits. Otherwise, you can do whatever you want. Any more questions? There will be 10 true or false, 4 short answers, 2 long answers. I will put old exams blank and with answers on B courses very shortly. Do not pick up the answer key, read it, and then be so proud of yourself that you can do the blank exam thereafter. Try the blank exam a couple of times until you've given it your best shot, and then look at the answers. Otherwise, it's a total waste of time. So you'll get the blank exam and the answers in separate files. So I'm helping you do the right thing. Any other questions? No? Things are going well? 70 degrees outside? Let's do some economics. So last time, what we did, and I'm sorry I only uploaded these this morning. Last night my computer didn't upload them. So these are new. I forgot to update the year here, but the slides are different from last year. So what we did last time is we learned about elasticities. You now know what they are, what they mean. They're these unitless measures of responsiveness that essentially tell us something about the percent change in one variable caused by a percent change in another variable. The way we used those was in own price elasticities of demand, where if the price of Hershey's rises by 1% and the quantity demanded of Hershey's falls by 0.5%, the elasticity of the demand for Hershey's at that point is roughly 0.5. It's exactly 0.5. The nice thing about elasticities is they're unitless. They tell us all kinds of great things, but most importantly, they're related to the slope of the demand curve and where you are on the demand curve. So our nice linear demand curve, the elasticity varies along the demand curve from very highly elastic at the top left to relatively inelastic at the bottom, right? So what we've got now, yes, that's right. See, even I have to check my intuition on this one. That's a tough one. Then we looked at income elasticities and said if your consumption of a good goes up, as income goes up, the good is normal, right? As you get richer, you want more of something. That implies a positive income elasticity. If your income goes up and you want less of a good, that means, as you get rich, you want to get out of that particular cup of noodles type world. That's an inferior good. And then we talked a little bit about backward bending angle curves, which basically related this concept of an income elasticity to our angle curves, right? So a positive income elasticity means there's an angle curve that's upward sloping. A negative income elasticity means the angle curve is downward sloping. Downward sloping angle curve is consistent with an inferior good. Upward sloping angle curve is consistent with a normal good. We know all these things. Max is talking really quickly, but you know this by now. If you don't, you better go home after this class and start studying for the midterm. Then we talked about this weird backward bending angle curve where what we said is a good to the same individual can be normal and inferior, right? So if you're really, really poor and you get a little bit more money, your angle curve might be upward sloping at low levels of income. You're really poor, you're hungry, you get an extra $5 like the gentleman who figured out Ernst Engel did. He's going to go out and buy some more mac and cheese, right? Eat some more. But once he starts his lucrative job as a historian of 19th century Germany, he's going to stop eating mac and cheese and he's going to start eating only truffled potatoes. All right? So that means as his income goes up at higher levels of income, mac and cheese become an inferior good. Right? So you have this backward bending potential angle curve. Not everybody's angle curves are backward bending, but they can be. All right? So very, very flexible model. Then we started something really terrifying. Max started talking about income and substitution effects. This is by far the most hated concept in intermediate microeconomics across the world. So this is sort of like telling your kid that going to the dentist is going to hurt. I took my kid to the dentist yesterday. He walks into the dentist office. He's like, I'm okay with this place as long as you don't give me a gold tooth. All right? So they assured him he wasn't going to get a gold tooth. So what I'm going to do today is the very nice sort of East Bay dentist treatment of income and substitution effects. There's like video monitors, video games. You get like organic toothbrushes for free. I'm going to try and make this as clear and easy as possible, but it is a hard concept, and I want to point out that this should take you some time to figure out in terms of understanding it and, more importantly, drawing it. So what we're worried about is the effects of price changes, right? We know intuitively that if the price of a good rises, generally speaking, we consume less of it, holding the rest of the world constant. Something becomes more expensive, darn it, I'm going to buy less of it. One exception here, of course, is a good where your demand is perfectly inelastic. If insulin becomes more expensive, you'll still consume the same amount and you'll just crowd out other things because you essentially die if you don't inject on a daily basis if you're insulin-dependent diabetic. But if you have if you have downward sloping demand curves, generally speaking, price goes up, you consume less of the particular good. Now, what we're doing in our heads now is I wanted to break down this effect of an increase in the price of a good into 2 things. And I outlined this at the end of last lecture, so I'll go through it a little bit quickly here. There's 2 things that happen. One, if the price of one good, let's say the price of Hershey's goes up, what you're doing, first of all, is you're facing a new exchange rate, right? Your nominal income stays the same. You still have $5 or $10 in your pocket like you did before. The price of Reese's stays the same, but the price of Hershey's has changed. It's now higher. So the exchange rate, the rate at which the store will let you trade in Reese's for more Hershey's, has changed in the favor of Reese's, because Reese's are now relatively less expensive, and this favor isn't really a word, to the disadvantage of Hershey's, because Hershey's are now relatively more expensive. So the first thing we've got is that the slope of my budget constraint has changed. The other thing that's going to happen is that you have less real income, right? Nominal income is the same. You still have the same $10 in your pocket, crisp $10 bill in your pocket that you did before. But because the price of Reese's stayed the same and the price of Hershey's went up, in terms of purchasing power terms, right? How many actual goods you can buy with the money in your pocket, that has gone down because one good has become more expensive. So your opportunity set really has shrunk because one price changed and your nominal income has stayed the same. So what I'm going to do is I'm going to take the overall impact on your consumption of Hershey's and Reese's from a price increase in Hershey's down into two particular moves, right? It's like decomposing a complex dance move. The new iPhone has this like slow-mo camera where you can really slow things down. And if you don't pay attention, you just see the overall move. But if you put it in slow-mo, right, the world sort of moves like this. Really cool. So I'm going to do the same thing here. In reality, it's one quick move from consumption before the price change to consumption after the price change. But I'm going to break this move down into a substitution effect, meaning the impact of the fact that you're now facing a new exchange rate, and then into this income effect, meaning you have less real purchasing power. Now this year, I've decided to become ambitious, right? I turned 40 recently, so I've got newfound ambition in life. Got to make up for the fact that I'm going bald, so I'm going to become better at explaining income and substitution effects. But I'm going to explain it slightly differently than I have in previous years, and let's see how it goes. If this bombs completely, I'll just explain it again the way I explained it last year. But it's sometimes nice to try out new things. So I tried this on the cat yesterday, and the cat was excited about it. So let's see how we do. So income and substitution effects work in two directions, right, in the sense that it works both for a price drop and a price increase. So this table here shows you what happens if a price of one good changes. So let's say the price of Hershey's drops, right? Hershey's go on sale, 2-for-1 special. Buy one bag, get one free. That's a 50% price drop in the price of Hershey's. So what you will always get in terms of substitution here, the good that becomes relatively less expensive is the one you will substitute towards. So what the substitution effect captures intuitively, and this is a tough one to get, and we'll draw it, and that often helps make us more sense of it, but what the substitution effect captures is I'm going to start at my original price of Hershey's, all right? I'm going to close my eyes, and I'm going to record the level of utility I get from my original Hershey's consumption. Now, what I'm going to do is I'm going to look at how many Hershey's and Reese's am I currently consuming at that level of utility and that price. Now I'm going to let the price of Hershey's drop. Happiness happens, right? Cheaper prices, we're all excited, we're sale hunters. But what I want to do in my mind now is I'm going to fix my level of utility at the original level of utility, and I just want to see how the mix of Reese's to Hershey's would be different were I to face that different exchange rate, but at the same level of utility, right? Because what happens in your souls, right, when you see a sale, it's this warm thing like, oh, President's Day is coming up. I can buy cheaper T-shirts. I don't know what you guys buy, right? But there's something that happens. It's like this anticipation of higher utility all of a sudden because a sale is happening, right? For the same resources, you get more stuff and you're happier. There's something fundamentally wrong with that, but we'll talk about that later, all right? The issue here, for this particular thought experiment, I want to take that anticipation of happiness away from you for the substitution effect, and I want to ask the question, if we hold your level of utility constant, if the price of one good changes, how would your mix of Reese's to Hershey's change if we held your utility constant? That's what the substitution effect says. It really just tries to get at the effect on product mix, right, in consumption from the new relative prices or this exchange rate. Now, the income effect here is a different thing. The income effect tells you that's exactly this thing. If a price goes down, you have more purchasing power, right? More power to you. That $20 bill, if you take it to the mall today, you're not going to get as much stuff as if you took that $20 bill to the mall on Monday's President's Day, right? On Monday. So prices change, and there's a real income effect in terms that your purchasing power goes up. Now, that's the income effect. The other one's the substitution effect. The one that drives students crazy is the substitution effect because it's totally made up. It lives in the brains of economists, and it doesn't really get observed in the real world or in terms of real behavior. And that's why you're at a great university, because we can do stuff like that. We have the luxury of spending 90 minutes together decomposing parts of behavior that you never actually observe. Does that mean it's useless? Actually, the exact opposite, right? Breaking down impacts of price changes on behavior, meaning on consumption choices in this way, shows us how responsive individuals are to price changes and why some individuals respond differently to price changes than others. And this is going to come down to two things. One, how big the substitution and income effect are. Are you going to change your product mix a lot or a little? And how income sensitive is your consumption, right? So how sensitive are you to this, like, sale prices go up, must go to mall, right? So how big is your income effect here? And the other thing is the sign of these effects. So you see positive, positive, positive here. What is Max talking about? The beautiful thing about the substitution effect is it always works in the same direction. If Hershey's become cheaper, you will substitute towards the relatively cheaper good towards Hershey's. If Hershey's become more expensive, you will substitute away from the relatively more expensive good towards Reese's. So the substitution effect is, the direction of the substitution effect is always clear. You always move away from the now relatively more expensive good, or you always move towards the now relatively less expensive good, right? Away from more expensive towards less expensive. That's the substitution effect, and graphically this will make a great amount of sense in a second. The income effect is not so clear. If all of a sudden you have more income, are you always going to consume more of a good? The answer is no, Max, I paid attention last time. Come on. I know that when my income goes up, I could have two responses. If the good's a normal good and my income goes up, I'm going to consume more of it. If my income goes up and I consume less of it, that means it's an inferior good. So whether the income effect sort of increases my consumption of something or decreases the consumption of something really depends on whether the good we're talking about is an inferior or a normal good. All right? So now this is the point where students usually are terrified because they're like, intuitively, I kind of see a glimpse, like a speck of how this might work, but this is really confusing. So let's try and draw this graphically, which is how I think this makes the most amount of sense. So let's put this into our Reese's Hershey's space and see if we can come up with a scenario here where we can isolate the substitution effect and the income effect, or decompose the overall impact of a price change into an income and substitution effect. So here we go. So this is what we're going to draw. It's a little bit messy. I had to draw it 14 times until I got it right. So if you don't get it right the first time, please don't drive yourself crazy about it. Okay, so let's try the following. Let's say income is $5. The price of Reese's is $1. And the price of Hershey's is 50 cents. Let's draw the budget constraint. Let's draw the budget constraint in the color we love. Sorry, this pen is a little bit thick here. Okay, so if price of Reese's is $1, you have $5 of income. You can afford, well, $5 divided by $1, you can afford $5. come on. Today's Tuesday, too. It's Microsoft Update date, so I'm waiting for this thing to reboot itself. Okay. If I spend all my money on Reese's, I get $5. If I spend all my money on Hershey's, if I spend all my money on Reese's, I can buy 5 Reese's. If I spend all my money on Hershey's, I can buy 10. So I'm going to draw my budget constraint here. Okay, so this here is the original budget constraint. Now what I'm going to do is I'm going to draw my tangency to this budget constraint, and it's going to be, and I picked that point intentionally because it works out beautifully in this particular setting. I picked it out to be at 3 Reese's and 4 Hershey's, okay? So right here. Why that is just it makes the example work out nicely. You could do it in all kinds of settings, but here that works well. And I'm also going to argue that the indifference curve that goes through this point also goes through 5, too. Okay? Why? It'll become apparent in a second. So I'm going to draw an indifference curve that goes like this. Not terrible. Okay. So Max, have you done anything new? No, we've done this 1,000 times by now, right? I'm sitting in the cafeteria, I'm drawing budget constraints and indifference curves on napkins. All you've done here is shown me that this is my original budget constraint. I have $5 to spend. Reese's cost twice what Hershey's cost, right? Reese's are $1, Hershey's are 50 cents. So this is my opportunity set, this big triangle right here. And you just drew me one of your indifference curves, and it happened to be the one that gets you the most utility possible out of that particular budget constraint right here. The point of tangency is this red dot right here. This red dot I'm going to call A, all right? Sorry, that's not a delta, that's an A. And at A, I want to note a couple of things. What's the marginal rate of transformation here? Rise over run of the budget constraint, right? So when you move 1 over, the budget constraint drops by 1/2. If you move 2 over, budget constraint drops by 1. So the marginal rate of transformation here is minus 0.5, or minus 1/2. How much money are you spending at that point A? That answer should come out of a barrel of a gun right there. $5, right? This is my $5 budget constraint. So you are spending $5. Okay. Nothing new here. I'm feeling pretty comfortable. Okay, here's a trick question, and that better come out like a choir, all right? What's the marginal rate of substitution at this point? Oh, I'm loving it. Most beautiful choir ever, right? Minus 1/2. There's a tangency point there, so at A, the marginal rate of substitution is equal to the marginal rate of transformation, so it's minus 1/2. Just checking our intuition. Okay, fasten your seatbelts, bite into that granola bar. Here we go. So now what I'm going to do is I'm going to say the price of Hershey's rises to $1. Income stays the same. Reese's stay the same. But price of Hershey's goes to $1. What happens to my budget constraint? Doesn't shift in parallel, right? It stays anchored at that point 5 Reese's because the price of Reese's didn't change and income didn't change, but it sort of swings inward, right? Until if I spend all my money on Hershey's now, I can only get 5 units. So in order to point that out here, let's draw the new budget constraint in blue. Okay, this is my new budget constraint. And you're feeling bored right now because you've done that before, right? When is Max going to do something new that I don't know? Now, okay? So when we derived demand, what we did is we took the old budget constraint, we let the price of Hershey's increase, rotated the budget constraint in, and then figured out what the new indifference curve is, and that told me the new bundle of Reese's and Hershey's on the new budget constraint. That's the overall move, right? That's the impact of a price change on consumption of Reese's and Hershey's. This income and substitution effect business is going to create some additional fun for us. So what did I say about the level of utility in order to get at measurement of the substitution effect? Does the level of utility change when I want to measure the substitution effect? No, right? So the thought experiment here is what would be my optimal consumption bundle if I face the new prices, right? Meaning the new ratio of prices, which is now no longer going to be minus 1/2, but it's going to be what? Minus 1, right? So the new ratio of prices is they're both $1, so it's minus 1. But I'm at my old level of utility, right? In econ nerd speak, what I'm trying to say is, if I were to consume at this old indifference curve, on this old indifference curve somewhere, what's the point of tangency of a fictitious budget constraint that has the same marginal rate of transformation as that new budget constraint right here? So I want to stay here, and I want to figure out the point of the indifference curve, right, which has the slope of the new budget constraint. So how do we do that? Well, the easiest way to do that is as follows, right? I wore laced shoes today. I'm a big fan of Velcro, right? Because, you know, Back to the Future. Okay, here's a shoelace. It's not a good color for multiple reasons. But what I'm going to do is I'm going to take my shoelace right here. That's a line with a slope of minus 1. Anybody disagree? No, we all agree. So what I'm going to do now is I want to find the point on my old indifference curve that also has the slope minus 1. Pow. I'm going to cheat a little, okay? Right there. So what I'm going to do essentially is I'm going to take my new budget constraint and I'm going to shift it out until it's exactly tangent to my old indifference curve. So draw the line that's parallel. I'm going to use the big dot theorem here. Actually, let's do green. Here we go. So what I'm going to do is this fake budget constraint right